The Cloudcast is sponsored by Intel Cloud for All, driving the creation of tens of thousands of clouds.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome to the Cloudcast. We're coming to you live from DockerCon here in Barcelona. Huge thanks to the Docker folks for having us as a media sponsor for the show. Today we have John Berger, evangelist at Project Calico. First of all, John, how you doing? It's been a long day. It's the end of the day. You almost made it through the first day.
It has been a long day. There's been a lot of people to talk to. It's been a really, really busy show, which has been great. So well worth turning up for. And yeah, I'm looking forward to the evening event.
Yeah, absolutely. Are you reaching the point you're starting to lose your voice from talking?
I'm just about hanging in there, I think.
I completely understand. So I will admit, slightly unfamiliar here. And so tell both myself and the listeners out there, what exactly is Project Calico? First of all, let's start there.
Sure. Project Calico is an open source virtual networking solution for containers, for VMs, for bare metal. And we set out to build basically the simplest solution for virtual networking that we could imagine. When you come to really nail scalability of these solutions, keeping them as simple as possible is a really important part of the design philosophy for us. And so key to that is that we're a no overlay solution. When people think about the way virtual networking solutions are normally created, they think, that means I build a network and then I have another network running over the top of that. And that underlying network gives me the connectivity that gets me from host to host. And, that's a totally valid way of doing that. But there are limitations to that. And one of the key limitations is, it's just a more complex solution. So what we tried to think was not starting with the existing tool set, what's the most natural way of building out virtual networking on top of this solution, but if I can design this network with a blank sheet of paper, what would I want it to look like? And what's the simplest possible network? And the simplest possible network is just a raw IP network.
Okay.
So we just have raw IP connectivity between each of the containers. Each container gets its own IP address. That can be an externally routable IP address, or that could be a purely internal IP address. And the traffic that's actually flowing from host to host is just a raw IP packet. It's the raw IP packet that the application sent, without any overlays, and that makes troubleshooting really very simple. All the tools that people will be familiar with, like ping, like traceroute, just work because there's nothing getting in the way of you visualizing exactly what's going on with your network and building your network the way you want your network to be built, rather than having networking requirements imposed by the containers.
Gotcha. And so I'm sure you probably got this question a lot in the booth today, and probably will again tomorrow. But so compare and contrast that against Docker networking, right? Is it complementary? Is it exclusive? Does it fit? Does it not fit? Tell us more about that, because obviously you're here, and I'm assuming it works.
Right? Absolutely, and that's good timing for that question as well, because so the Docker folk have in 1.9 just turned libnetwork, their networking solution, from the experimental branch onto the mainstream. So that's now a sort of mainstream part of Docker.
And that allows plugins.
And so that whole philosophy is the Docker folk ship out of the box something which gets you going and is perfectly fine solution in a number of use cases, but they allow you to switch in a different networking solution if that's something that you need for your use case. And so we fully support that. We supported libnetwork from day one. And the key value that we add is that we remove that overlay and therefore end up with a simpler, better performing and better scaling solution than one that is dependent on overlays.
Sure. And is there so the use cases obviously there are get going very quickly, simplicity at scale. Is there any kind of, sometimes everyone kind of goes, well, what about this or what about that? Is there any things you didn't necessarily think of at times of people using the product maybe outside of those use cases or using it in any other way?
I think one of the things that is now absolutely front and center when you look at our website, it's really obvious that we do this, but was actually not something that we really had in mind when we first created the solution, was the value that we can bring on the policy enforcement front. So because we use raw IP networking, then rather than an overlay, we have to have a different mechanism to provide network isolation and constraining which containers are allowed to talk to which other containers. And most people think of that as, you've got these multiple logical networks, and if you're on this network on the left-hand side, then you can't talk to a container in the network on the right-hand side. And that's a sort of slightly now old-fashioned, in my view, way of thinking about networking.
It's amazing how quickly things are getting to be old-fashioned.
Yeah, exactly. Legacy is anything you did yesterday. But if you think about the world of microservices and architecture where you're not just thinking, okay, mentally each of my containers is just what used to be a physical machine 10 years ago, but you're really thinking this is just a small component that could need to talk to a subset of the other components I have in my architecture, then having the network impose requirements on which containers are allowed to talk to which other containers is actually problematic for you. That actually limits the way you can deploy your own application. So with what we're calling fine-grained policy control, you have the ability to, in a very simple manner, tell the network which containers are allowed to talk to which other containers. And that's not just these are in this network and these are in this other network. You can actually describe exactly who's allowed to talk to who,
right?
In a way that then minimizes your security problems, because you're not giving a container more in the way of permissions than the minimum it needs to do its job.
Sure.
And that wasn't something that we really thought was a fundamental part of the solution to start with, but I guess it's just one of those nice side effects when you've got a good design,
right?
Like nice things pop out of that.
Yep.
And that was something that took our customers to point out the value of it, really, rather than something that we really spotted ourselves. So
so it's almost like there's a policy manager kind of running off on the side, controlling the policies and pushing them down, kind of thing. Because when you and I were talking in your booth earlier, you were giving this example of how do you scale out sideways, if you will,
right,
and have that control plane but not be in the data path,
right,
and have that policy manager manage all of those things at scale.
Exactly. So the way we think of it is that you've essentially got a distributed firewall running on every single host in your system. And the first thing a lot of people will think when I say distributed firewall running on every single host is, wait a minute, what are you installing in my kernel? Because that just sounds like
right.
you're making trouble for me. And the great news is it's already there. Everything we need on the data path is already a core part of the Linux kernel. We're using kernel routing to just move packets from A to B, and we're using IP tables to limit the connectivity to various containers. And I'm pretty much willing to bet of all of the technologies that people are talking about today in this space, there is nothing more field-hardened than the Linux kernel, right? That's not something that's going to be high on your list of, well, it's only been around for 10 minutes and I'm not sure anyone else is using it, right? This works, and we know that works. And we don't need to do anything to that. So your data path is bulletproof. And it's already deployed. You already have it. And what we're doing is, as you say, distributing agents onto each of the hosts which program that data path to do the right thing. And that's a really efficient way of running that network.
Well, that makes sense. And what are some of the, when we say it scales, right? What kind of, tell me about scale, because everyone thinks of scale differently, right?
Yep.
What's your definition of scale?
What's my definition of scale? So what we've already said publicly when we released our version 1.0 of Calico back in August was that we'd got that running up to 50,000 containers, which is a pretty decent number.
Sure.
It's definitely beyond a couple of the barriers where you think, these guys are not messing around.
Right.
We've not rested on our laurels. We keep keeping pushing that number because we do think of the scale as just such a fundamental part of what makes Calico special that we really don't want to give up until we know how far we can go, and we haven't hit that limit yet. We are internally pushing beyond the 100,000 container number, and it's all very exciting, and it's a lot of fun to do that testing. Yeah. I don't know how far we're going to go, and I don't know how far we need to go in order to say.
Well, yeah, and there's this concept of need versus want there, without a doubt. Because I was talking to somebody on the show floor earlier, and I'll kind of withhold names and companies, but I will say it's at times it's almost like 50,000 is the new gold standard, if you will, of everyone just asked, does it scale to 50,000? Because, the keynote today, right? They shared Swarm up to 50,000 kind of thing. So that's the new measurement everyone's using. But at the same time, one of the conversations I had was somebody saying, well, I have one customer who is running maybe 6,000 containers and no one's nowhere near 50,000 yet. And so it's the idea of the numbers, we call them hero numbers, right? They sound super awesome, but at the same time, who needs them? Now, with everything moving as quickly as it can, and heck, by the end of the year, who knows? Maybe they will be, right? Because everything's moving so fast. And it's interesting to me to have that conversation of, okay, is that good? Is that bad? Will anybody ever do that?
I think it's great to be here at DockerCon, where you're hearing so many success stories of people who are already deploying containers. It's not the future for them. It's what they're doing at the moment in production. But this is also just the tip of the iceberg in terms of deployment. And there are some companies that have done a brilliant job of really understanding what it means to build that microservices architecture, defining to the rest of the world what it means, your Googles and so on, who are just, knocking scale out of the park. But there's a lot of other people out there who haven't yet really understood, I think, what a microservices architecture can do for them and what value they can get. And therefore, I think scale is going to be a big part of the future for a lot of people. And even people don't really understand it yet, I think they're going to need to and want to, and that's the value that this whole ecosystem can bring to them. I'm hearing now a lot of conversations where instead of people just saying, well, is scale possible? Is it even possible to deploy containers? It's now, okay, I've got containers in production, great, relatively modest scale, that's fine, I really like the way it works. How do I now push that into an architecture? How do I build my applications in such a way that they're not the bottleneck going forward? I think that's an interesting thing for the community to solve.
And a lot of times what people don't consider is, okay, I want this loosely coupled microservices kind of architecture. Well, in that, okay, you bought yourself scale, you bought yourself a lot of the advantage of this loose coupling, but at the same time you have more connection points, and so the connection points get more complex, while the services themselves get smaller and simpler. And so it's not everything has trade-offs. And it just makes sense then, if you're going to have more trade-offs of you're going to have a higher amount of complexity in your intercoupling of your services, you definitely want the network to be as simple as possible.
Yeah, and you want the network to look the way the application needs the network to look. You don't want the network to be imposing limitations on the application.
Right.
Because
architecting to the network.
Right, absolutely. You want to say, network, please do this for me, not network, what can you do?
This kind of works like that, and if I do this,
and that's why it is important to us that the APIs into the network are generic enough and based on what the application wants to achieve, not how the network should achieve it.
Yes.
Yeah, you don't want to be constraining the network artificially when it actually has the ability to do more for you.
Yeah, no, that's a great point. All right, we're kind of out of time here. So, John, where can everyone find out more about you, about Project Calico, and everything else you guys have going on?
Sure. So projectcalico.org is a great place, starting off point for everything that we have. You'll see links there to everything we have on GitHub, everything, a series of blog posts that keep people informed on what's going on. There'll be links there to our Slack channel. So if you want to get involved in the community, then we've got a pretty vibrant community on Slack now, which is great. So feel free to go and request an invite there on the website. That's really the sort of the core place to point you all at, and at Project Calico on Twitter.
Fantastic. All right. So, John, thank you very much for your time today, and thank you everyone for listening, and we'll talk soon. Thank you, everybody.
Great. Thanks, Aaron.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.